Here we are again. What was the last comparison test that we just checked? Oh, come on, you didn't do your homework? It's on your MyMathLab.
Oh, I remember.
I even gave you a hint. I gave you a word. The last two tests that we had, that we lectured on. I don't think it's on your phone, Talia.
Okay, sorry.
I was hoping you'd say, well, it is. I took a picture of all my notes.
Oh,
and
actually?
Yeah, don't tell me you did that.
No, actually, I might have it.
All right. We did the direct comparison test, and we did the
That's what I
limit
was gonna
comparison
get.
test. And I have a homework assignment
Yeah,
for you
see, I
on
did have
that.
it.
Show me.
Limit comparison test.
You have it on there for real.
Yeah.
Well, I have my notes right here. Comparison of series.
It's the thing where I tell you, like, if you get it wrong, it will show you how to do it, and then once you learn how to do it.
On MyMathLab.
Oh, no.
Or on Cons.
On Cons. It shows you how
Oh,
to
you
do
brought it up on Cons right now.
On paper.
Okay.
Yeah, it shows you how to do it.
Yeah, it does. It surely does. And you should get it done. I'm just disturbed that I checked the latest
I did it.
MyMathLab grades, and of the 3 that are in here, only 1 had grades down. Now, you said you were working on cons and cons and cons. I looked up your cons. You weren't working on no cons. So you had 3 hours of class time. What did Adam get done?
Well, we were working on the assignment that the teacher gave us.
Teacher didn't give you any assignments.
Yeah, the first one did.
Mm-mm.
She gave us a paper.
There was no paper.
Oh, yes.
You had online work.
There was a paper, right? There was a paper she gave us.
Oh, yeah, there was.
The group quiz.
Oh, that one, the 8 tests.
Yeah, that one.
Yeah, okay. That's right. She did tell me that you were here and what you did in here. She told me what everybody was doing. She's
Yeah,
strict.
what was they doing?
She's real strict. You were working.
Okay. She better.
Adam had to be told all the time.
No, she was talking about her grandson with me.
She loves her grandsons.
She really-
All right, so what's the next test?
Right here it says alternating.
It says alternating, and we already looked at alternating, but we didn't really prove what makes it converge, other than if you can apply it to one of the other tests, perhaps. So alternating is on the AP test, and it's, oh,
Mr. Cartwright,
yes, ma'am.
we need Gilberto Aguilera to the front. He's leaving.
Okay, thank you.
Thank you.
Well, Gilbert, it's going to be on YouTube,
Okay.
and it's already assigned on Khan Academy. Okay.
So your 2 worst students are here.
Hey, don't talk about Talia like that.
Oh, like,
Your worst student is here with Talia.
Hold on, I gotta go do work.
You are exactly what you want to be.
Bye, Gilberto.
That means I'll be sexy one day.
You just might.
you're so
It's not today, and it won't be tomorrow, but
I'll be one day.
one day. Who knows? Maybe the girl really says he's the bomb.
Not Gilbert. Oh, just kidding.
He's a nice guy.
Ask Talia.
He's a nice guy, isn't he?
yeah.
Yeah.
No, he's not. Last year he would hit me.
Oh, sorry.
Ask me.
All right, it goes. And I'm lecturing to you two now, just as if I had a class
We can do our
of,
Academy.
if we get done with this, we can do a lot of things. We're going to use the alternating series test to determine whether an infinite series converges, which is what we've been doing. We're going to also use something called a remainder. And you're wondering, well, what is a remainder in English? When I say remainder, when do you get remainders?
Leftovers.
Leftovers after what?
After the amount, the equal amount.
I'm going to write that out. Leftovers
After the given amount.
after the given.
The,
Expected?
no, the full.
What are you going to do with that full, though?
After the,
After.
We're just getting dumb things.
we're not, we know.
No, but I know you can say something that's true. Leftovers after what?
After the
Are you talking about food leftovers? Are you talking about leftovers after cookies?
Yeah.
Or leftover money?
It could be money.
Okay, so how would you get the leftovers?
Extra.
Actually,
Extra after you've done what?
you find the amount.
You find
You spend
the.
the necessary.
Say it again?
You spend the necessary.
You spend, which means when
So
you
it's like-
spend, you take it away from what?
The total.
The total. So You could say if you had a total amount minus what you spend will be the leftovers, right? Which is your remainder. It's your remainder after subtraction, right? Well, we haven't subtracted with series, so I wonder what that's going to be all about. Maybe right now you're dying to know. You'll have to wait till we get there. Then there are convergent series that we've been doing with the nth term test was for divergence, but the p-series test was for convergence. What other tests we've done? We've done the integral test for convergence. We have done, what was on your paper? You said you worked on it with that, the sub gave you.
The divergence convergence test.
Of what? Give me another one. I named a lot. I named p-series. I named integral test. What's the one that started letter G? Mr. Goldstein taught it. Not really. He taught a class.
I don't have that guy. Oh, geometry.
Geometric series. We had, the last test was the limit comparison, where we compared the limits of two different functions, and one function was bigger than the other, so you can make a decision about the limits. Then we did the direct comparison, which also checked that if one function is always bigger than another function and the big function converges, then the small function had to converge. That was the direct comparison. So we had a lot of tests, but there's something they can be called. They can be called, when we do a series like alternating, it could converge absolutely or it could converge conditionally. Vocabulary words. So we'll talk about that. You'll see it in cons. Then in case you wanted to, you could rearrange the infinite series to create a different sum, which is, I don't know if that's tested on AP, but it definitely is in all the college books. So we'll see what we got. All right, you recognize this series? Tell me how you know, just by looking at this page, that it's alternating. What is alternating? Come on, Adam. You're bright. What's alternating? What does alternating mean?
Oh, it's from negative to positive.
Very good. Except this one didn't go from negative to positive. This one went from positive to negative. But what you're saying is you could go from negative to positive, just as well as positive to negative, positive, right? To negative. What would have to change in this problem to, right now the one he gave me goes from positive to positive. What would have to change in this problem to make it go the other way?
Reciprocate the equation.
Don't use any fancy words. There's one thing you could do very simply. I'm going to zoom in on it. There's something in here. What's changing if you're going from negative to positive versus positive to negative?
Change the negatives to a positive.
Well, yeah, but if you can't change just -1 to a positive, then you'll never have negatives. What if, see here, why is this first one number positive? Look what happens. N is 0. What's a -1 to the 0 power?
1.
Do you see how that 1 stripped the negative off? What if I started at 1? What would have happened? What's -1 to the 1?
Negative.
Oh, you see how simple that was? If I started from a 0 versus starting from a 1 changed if I'm going negative to positive versus positive to negative. And it's not a big deal because who cares about the first term 0 or the first term at 1? We're doing infinite series. We care about what's happening in the future a mile away. We don't really care what's happening at the beginning. So there's one thing that Adam saw that we could probably fix. What if I leave it as 0? What else could I change up here to change the plus, minus, like that? Instead of going to n, right here, you could go -1 raised to the n plus 1 times 1/2 to the n plus 1. Or, for that matter, you can put anything you want here.
Yeah, but wouldn't that still be negative?
Not really, because right now, look what happens. If you plug in a 0 now, you get 0 plus 1.
Yeah, that's still.
What's a negative 1 to the first power?
Negative one?
It would have forced it to be negative now. So that's interesting. So I need you just to pay attention to what's happening with this negative 1. Is it to the n power or is it to the n plus 1 power? Because that's what can cause it to start from negative or start at positive, depending on what you are doing, n equals to what number. If I'm starting at 1 to n, 1 to infinity, I mean, if I start at 1, then I use the first one, well, that's going to give me a negative. Then if n is 2, that's going to give me a positive. If n is 3, it's going to give me a negative. If I go to this one here, if I start at 1, that it starts as positive, then n is 2,
Oh,
negative.
oh,
You're right here. It was positive, negative. Where when it was just an n, it was negative, negative, positive. So it's not a big deal. It's just something to look at. In this case, he has a 1 minus a half plus a fourth minus an eighth plus a 16. Talia, take a guess at the next term. Plus or minus
Where?
after the 1/16.
Oh, minus.
Minus what?
Do
Do you see the pattern?
2?
Yeah, it is. Just a 32?
1 over 32.
1 over 32. That's exactly right. That's if you did 1, 2, 3, 4, 5, 6 terms. By the way, if I leave it at 5 terms, or whether I leave it at 6 terms, that's called a partial sum. Partial sum. If I keep on going forever, it's called the sum. Because you have everything all the way to infinity. It means you're adding every number up forever and ever and ever. This is an alternating geometric series with an r equals a negative half. Well, we all know about what that means. When r is less than 1, it converges. So this one converges. In other words, it doesn't even matter if you have the pluses and minuses. 1 plus a half plus a fourth plus an eighth. That converges anyway. It keeps on going, and it does converge. And it has a sum. Remember the sum? The sum of a geometric series is a sub 1 divided by 1 minus r. A sub 1 being the first term you're using. 1. 1 over 1 minus a half. 1 over a half. 2. This, with all the pluses, adds up to 2. So it converges. Well, look what happens here if I have the pluses and minuses. If the whole thing is positive numbers adds up to 2, wouldn't it add up to less than a 2 if you have negatives being pulled out? Instead of adding a half, I'm taking away a half. Instead of adding an eighth, I could be taking away an eighth. So it's going to be less than 2. So it still can work. But that's not what he's doing. He's not doing geometric today. I'm just bringing in other terminology that we already had. Making sure I'm still recording because my a sub n was, where's it at? Where was the c? Oh, right here. My a sub, this is my a sub n right here, 1/2. Everything else was the switch. Positive, negative. So a sub n was the 1/2. So what habit of switching off? All right. How do I know
Wouldn't it be less than 1?
what?
Answer?
If you were to do the alternating?
No, like if you were to continue on that path.
All positives or you're alternating?
You're alternating.
I don't know if it'll be less than 1, but it'll be definitely less than 2. Because the whole thing with pluses was 2. It really does. If you had all those numbers forever and ever, and Johnny was way in the future, coming our way with a broom, sweeping all the infinite numbers up into a pile, it would add up to $2. Let's call all that stuff money. All that money, like start with $1, then get a half $1, then get a fourth of a dollar, then an eighth of a dollar, then a 16th of a dollar, and then a 32, like you said, of a dollar, and keep on going. You keep adding that up and sweep it all up, it all add up to $2, which is kind of, to me, a mystery. How can an infinite set of numbers add up to 2? But it does. All right. I'll have to look into that one about, does that alternating one add up to less than 1?
I think it's less than 1.
And I, you're actually talking about something that we can do. We had 1 minus a half plus a fourth minus an eighth. Do I have it right?
Yeah.
Plus a 16th. Yes, because Talia said a minus 1 over 32. Then it's going to be a plus 1 over 64. Let me pause there for a minute. Minus something. You know the last bullet on that slide said about rearranging terms? What if I rearrange terms? And what if I take all the positives? 1 plus 1/4 plus 1/16 plus 1/64 plus ... You know, if I had all of those, that has to add up to less than 2 because it doesn't have the other numbers. Let's add up the negatives. Negative half, negative 1/8, negative 1/32, negative ... Just look at these series you have right now. You could write the first one, 1 over 2 to the 0, plus 1 over 2 squared, plus 1 over 2 to the 4th, plus 1 over 2 to the, I'm guessing, 0, 2, 4, 6. I don't know, 2, 4, 6, 8, 16, 32. Yes, it is. So 1 over 2 to the 6. You're thinking that if I take all of these positives and take away the sum of all of these, I didn't do the negatives yet. These are the negatives. Take all the positives and subtract the negatives, you think it might be less than 1 altogether. Well, let's just take a look at it. We know a half is 0.5. We can start listing it, 0.5. We know 1/8 is 0.125. We know that what was after 1/8? It was
132.
132, thank you. 132, you got a calculator?
It's 0.0125, I think.
Really? Key it in, let's just show off. Because I don't know.
Oh, 0.03125.
See what happened here? It got very super small.
Yeah.
So
It'd
what?
still be less than 1.
So if it's less than 1, if all these negatives are less than 1, then the answer probably won't be, the whole thing won't be less than 1. These are the negatives,
Yeah,
less than 1.
Positives are also.
But the whole thing added up to 2. So you'd have to take 2 and subtract this answer. And if this is all less than 1, then our infinite series still would probably be more than 1. Probably, but not less than 1. Unless we continue, what would the next one after 132? 2.
164 and then 128.
Are we doing the right ones? It was a negative. Oh wait, are we doing the right ones?
Those are the negatives. The top ones are the positives.
The top ones are the positives?
With the 1 and the 1/4, 116.
Oh, okay. I don't think I added the right numbers here. These are my positives.
Yeah.
My negatives were a negative half. I'm sorry. Then this number, negative half. Okay, I had that. Negative half, negative eighth, negative 32. Yeah, the 64 is not the next negative.
Yeah, it's 1 over 128.
Minus 1 over 128. How big is that one? It's even smaller than that one. 0.00.
0.00781.
You see what's happening? So this is 0.6, and it's not even getting to it's not even going to get a 0.6 0.65. Then the next one will be 0.65 something. So you can start looking at those partial sums and deciding what do they add up to. This is way above the lesson, but it is related to rearranging terms. I added up all the positives, added up all the negatives, and just get an idea what's really happening. Anyway, back to what this slide was. How do we know an alternating series test converges? There are two things that have to be true. First of all, the summation as n goes to 1, and it doesn't matter what number they start out with. They could have said 0, but they could have said 2. As n goes from 1 to infinity of a negative 1 to the n, which means obviously he's starting out with negative, positive, negative, whatever. A sub n. So there's some term a sub n in front of it. Well, we had it, look at the other page. What I'm saying is you have a series with a switch, a sub n, or it could be the switch with an n plus 1, meaning what? It doesn't matter which is first, positive or negative, doesn't matter. A sub n. Here's what we had to know. What he did, he just showed there are two kinds of alternating series. One that starts negative, one that starts positive. Who cares? This thing converges when the limit as n goes to infinity of a sub n equals to 0. This has to be true. And a sub n plus 1 is less than or equal to a sub n for every single n. Talia, what does that mean? What does this gobbledygook mean? A sub n plus 1 less than a sub n. What do you think it means?
So if that's true, it converges.
Well, this has to be true, and this. But what does this mean, though? What does number 2 mean? What does a sub n plus 1 being less than a sub n mean in English? How would you tell your sibling? Not that they would understand the limit as n goes to infinity of a sub n is 0, but just in case, what does this part mean? Okay, while you're thinking, both of you, I'm going to let n start out at 1, then it's going to be a 2, and then it's going to be a 3, and then it's going to be a 4, then it's going to be a 5, and so forth, right? So watch this. If n is 1, a sub n plus 1 will be a 2, less than or equal to, so that's a sub 2, a sub 1. What if n is a 2? I plug it in. A sub n plus 1 means a sub 3 is less than a sub 2. See what's happening as n counts down?
So it's getting lower. So,
Th-
so the higher the number, the lower
The higher the number. I think you know what the answer is. You're not saying it right though.
the higher the n is, the lower the number, the amount. So like a sub 3 could be 1 over
A sub 3 must be less than what?
a sub 2.
A sub 2. A sub 4 must be less than.
A sub 3.
So what's going on here? It's decreasing. Always. That's exactly what it is. It's decreasing. So you don't care about the switches anymore. Take a look at just the numbers. Like we had a 1, then we had a 1/2, then we had a 1/4, then we had a 1/8, then we had a 1/16, then Talia's was 1/32, right? Is 1 greater, is 1, see, this is the one on the bigger one. That would be the a sub 1. Is a, does that get up, doesn't light up over there. A sub 1 is a 1. This would be a sub 2. Is 1/2 less than or equal to 1?
Yes.
True. Is 1/4 less than or equal to 1/2?
Yeah.
True. Is 1/8 less than or equal to 1/4? I mean, look, it's common sense, right? The bigger the denominator goes, the smaller the fraction, the smaller the number, right? So that's what's happening. I like what Adam said. It's decreasing every single time. So those are your two conditions. So let's see if we can practice. Are you sure?
Yes.
Okay. Problem. Determine if this one converges. Now, I don't even care about this right now. That's a switch. I don't care about it. To see if this converges, I need to do two things. The first thing I need to do is the limit as n goes to infinity of a sub n. What's a sub n in this problem?
1 to infinity.
What is a sub n? What's the term that we're looking at, evaluating? It's everything that doesn't have the switch.
1 over n.
1 over n. Talia, you've had this before. What's the limit of 1 over n as n goes to infinity?
0.
Tell me why. Because back in Calculus AB, remember we talked about what would happen if you bought a pizza, you take it home, and what city you live in? So the football team of Mac High shows up for dinner, and all you have is one pizza. That's the same thing as n's going to infinity. You know what? They love that pizza so much. You know who they called?
Who?
They called the boys basketball team too. They joined you. You still only have one pizza. How much pizza did you get?
0.
0. Well, you got to smell it. Even if they passed the pizza around and everybody took a bite, you're not getting very much. Because don't take a big bite. We got to split this with 70 people.
Yeah, but Talia doesn't eat, right?
Yeah, I do.
So, first condition is true. What's the second condition? The one that Adam figured out. A sub n has to be less than or equal to a sub n plus 1. Now, we could list the numbers like I did a minute ago.
The opposite way?
This is a sub n. This is a sub n sub 1 is bigger. Because
What?
what did I write over there?
No, it's the other way. Oh.
You don't have to yell at me, make me cry. I'm already crying because my
Isn't
eye.
it a sub n squared?
No. Talia is right. It was a sub n plus 1. The 1 second has to be bigger than the first one. The third has to be bigger than the... So what we want to do is this. Here's the simple thing you can do. This is a sub n. So to write a sub n plus 1, I'm going to write it as 1 over n plus 1. And I'm going to ask the question, is this true that 1 over n plus 1 is less than or equal to 1 over n?
It's true. That's half is less than or equal to 1. So it's true.
Well, how'd you do it though? Well, yeah, but you got to do it generically. You got to make sure every term. How do I know every term decreases unless I list every single term? So look at, I have an expression here.
You just plug in 1.
Well, I don't want to plug in anything. I just want to solve this thing and see what it looks like. Watch this. What if I take this n and I multiply it straight up? That gives me n.
It's always going to be less.
What if I take n plus 1 and multiply it straight up? I get n plus 1. And the sign still says that. Less than. Is n always less than n added 1 more?
Yes.
Always, always? No matter what n you chose?
So
Then that's true. So what does this mean if both conditions are true?
it converges.
It converges. Now, you have to be, what happened here? Why is that not showing me? It's weird. Oh, where'd my eraser go? Who messed up my eraser? Wait, that's my eraser. Never mind. I thought that was my eraser. That's my pen. That's my eraser. It's supposed to erase. Oh, wait. I made an arrow without trying. Okay. Eraser. Where'd you go?
Sandy looks like she's having a good time.
What's not to have? There's my eraser. I don't know why I was blind here. So we have to say, we will say The summation is n goes to 1 to infinity of -1. That's my switch. Raised to the n plus 1 over times 1 over n converges by the alternating series. The other day, some of you would have said it converged alternating series because you saw it like a telescope, getting smaller and smaller and smaller, bouncing like this, up, down, like this. And yes, probably you would said it converged, probably, but now you know exactly the official words, okay? And I left a blank for another problem, but I got problems at the end of this, so I'm gonna leave those blanks. There's your solution. It looks like we got it right. Okay, we are now on. Now, in the remainder, and remember what Adam said? He said it's the leftovers, and you said it's the leftovers after you have money and you spend it. You have your change, your leftover. So, remainder. Well, maybe I should jump to another problem. Let's do that. Talk about the remainder. For a convergent, okay, this is important. Underline the word convergent. It has to be convergent. For a convergent alternating series, the partial sum S of n means how many terms am I going to use? S of 4 is something. I can take 5, that's something. S of 6 could be something. Those are called partial sums. They are not to infinity. They're only a set of them, okay? The partial sum S of n can be used, or can be useful, approximation for the sum of S, which is what Adam was doing earlier. He was approximating what it was going to be just as well. Well, guess what, Adam? You're on your way to doing something you were thinking about. The approximation for the sum of S for a series, which is called the error, is S equals to S of n. In other words, using the approximation for S of n will approximate S. It'll be very close. And it'll have a remainder called R of n, which here's the remainder. Take the total and subtract how much you spent. That gives you your remainder, the leftovers. You take the total sum, if we knew what it was, and we subtract what we spent. Well, if you think about it, we're almost on our way to success here. So here's your theorem. If a convergent alternating series satisfies the conditions that a sub n plus 1 is less than or equal to a sub n, hello, it has to, because you said it was a convergent series. But the thing about it is, it could have been a convergent series that was not alternating. And so this is definitely for an alternating series. Then the absolute value of the remainder, because the remainder could be negatives and positives. Remember me and Adam, we were adding up those numbers?
Oh, yeah.
The remainder can be negative, then it's positive, then it's negative. Well, you take the absolute value of the remainder involved in the approximating the sum S by, not word by, my eyes are bad, S of n, approximating the sum of S by using our partial sum is less than or equal to the first neglected term. Neglected? Well, if I have S is equal to a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, and I decide to quit getting terms, oh, by the way, that's just what I'm saying. Here's a series. If I'm only going to use this, I would call this S of 4. If I want S of 6, then I'd have to do a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. What is the first neglected term in SO4? What's the first term that I'm not using? I'm using 1, I'm using 2, I'm using 3, I'm using 4. Am I using 5?
No.
That's my first neglected term, a sub 5. This one here, my first neglected term would be a sub 7. What he says here, this is cool, that the remainder is less than or equal to the first neglected term. My remainder has to be less than that or equal to it. Less than or equal. Okay? That's the rule. So it gets kind of tricky. It's really funny how it's worded here. The true sum, take away the amount that you spent, is equal to the remainder. And the absolute value of that remainder is less than or equal to the first neglected term, a sub n plus 1. Because I only wanted 4, but the fifth term will be what I use to determine. Okay, so here is your series. Ooh, I like it. Ask you a question first of all. Is it alternating?
Yeah.
I don't have to be a genius. Positive, negative, positive, negative. But yeah, the pattern continues. Or it has a switch, right? It has a switch. Next thing, a sub n is 1 over n factorial. What's the limit as n goes to infinity of 1 over n factorial? Don't think too hard. You're going to infinity. Even if I went to 1,000, what's 1 over 1,000 factorial? That's 1 over 1,000 times 999 times 900. What? Say it again. You think this is 0? Yeah, it is. It's a big number, right?
Because it's still 1 over infinity.
1 over exactly. Infinity factorial is still a big infinity, right? Now I also have to ask myself, is this
infinity factorial even possible?
No, because we don't know where to start, do we?
We don't know where to end.
All right, we can do this. 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 ... times infinity. Right? So you're right. It's a big number. So let's check it out. This is condition 1. Condition 2 does this. A sub n plus 1 has to always be less than a sub n. So let's try it out. 1 over n plus 1 factorial has to be less than or equal to 1 over n factorial. Yes or no?
Yes.
Is this denominator always going to be bigger than this denominator?
Yeah.
Then this number has to be smaller always, right, Talia?
Yeah.
So this is true as well. Why did I do this? I have to prove that it's a convergent alternating series. So it is convergent. So convergent alternating series. It checks out. It's good to go. Now, what else do I have to check now? I need to find out, he wants me to approximate the sum. Well, the sum is equal to, let's see, how many terms do I have here? 1, 2, 3. It's the sum of 6 terms plus the remainder.
7.
Remainder isn't it infinity?
Well, you're right. The remainder, I'll put n, and n has to be the first number skipped. So look at the sum has to be the sum of the 6 terms. Would you agree that it's also plus or minus though? Because how do you know what S of 7 is? Could be positive. Not S of 7. I don't mean S of 7. That's a sum. I mean A sub 7. Right? The 7th term, it could be plus or minus. will be my approximation for the sum. So let's do this. I might need help. Let's see. I guess, help me out, get these numbers. Let's see what S of 6 looks like. It's 1 over 1 factorial. What's 1 over 1 factorial? 1 over 1. Then it's a minus. What's 1 over 2 factorial? Good job. Plus. What's 1 over 3 factorial? Nice job. Minus. Talia, help us out. What's 1 over 4 factorial?
24.
Are you letting him take all the glory? 4 times 3 times 2 times 1.
I can't do math in my head, that's why.
He's fast. 1 over, and for those that are listening and they're watching the video, Adam's doing that in his head. He doesn't even have a calculator on his desk. So that's 1, 2, 3, 4. We need 2 more terms. Plus 1 over what?
120.
I think it is 120. Minus 6 times 5 times 4 times 3 times 2 times 1, right?
30 is 360 times 2. 720. 1 over 720.
Minus 1 over 720. That's 1 term, 2 term, 3 term, 4 term, 5. There it is. Okay. Got a calculator?
I lent it to Vicky, remember?
But she didn't give it back to you?
Oh, it's because I haven't seen her, like, it doesn't matter.
Adam, go grab a calculator on the corner of my desk there. Oh, wait, it's right here. It's right there. Pass it over to Talia. We'll put her to work now. Okay, we'll help you out, Talia. What is 1 minus a half?
1 minus, oh, that's like a half.
Thank you. So type in 0.5. 0.5, I'm going to add it to 1 divided by 6.
That's 1 divided by
Hit enter. What do you got?
0.66.
Okay, minus
Minus
1 divided by 24.
1 divided by 24.
Hit enter.
0.625.
Okay, you already hit enter. Add it, plus
Plus
1 over 120.
0.633.
Minus 1 over 720. If Adam's right.
Well, nah. 0.6319.
Give me 2 more decimals.
4.
4. All right. So there's my partial. There's my partial. But remember, the total sum is equal to this partial, 0.631944, plus or minus what, Adam?
Plus or minus.
What number would go here was a minus, now it's a plus what? Doesn't really matter if it's plus or minus. What's that next fraction? This was 1 factorial, 2 factorial, 3, 4, 5, 6, 7 factorial. Which, by the way, she has in her calculator. You have it if you press math, probability.
You want 7 factorial?
You see the factorial symbol?
42.
Where's probability?
Did you press math? Number?
Okay, yeah.
Do you see probability yet?
No.
Okay, I'm gonna pause the video while I go and look at my calculator. Okay, so we're back again. What was 1 over 7 factorial was how much?
50, 40.
1 over 50, 40, whatever that is.
I put 7
So
times
Talia, we have an interval of our sum going from here to here. So take the point, your answer you have in your calculator, 0.631544, add it to 1 divided by 540. That's going to go over here. Oh, wait, I don't need plus or minus. You know why?
Wow.
We're going to do absolute value of the remainder. Yeah, we're just going to do absolute value. So what is plus 1,544?
What?
What is this number plus 1 over 544? Your answer you had. Add it to 1 divided by 5. I lost track what that number was. 5 what?
50,
5040.
40.
5040. Okay.
So that's 0.63214.
63214.
Yeah.
And I just still kind of want to go the other way. What's that number and take away the 1 over 50/40?
This thing isn't an eagle up to click it, so I need to type.
I know, it's a cheap calculator.
-1.6317455.
Okay, that's a lot. 0.31731 or 36? Wait. Can't be 31 and 63. You're not subtracting that much from 0.63. Did I read it wrong?
No, I put .6317.
Oh, thank you. 631. Okay. 6317, 63214. Let's see if we're right. This is my approximation for the sum. 63. Yes, we have it. Usually I type them in or copy. Let's see what he's got. Okay, look he did the same thing as me. There's the alternating, he's testing those to make sure that's true. Next step, 63214. Good job, Talia. Thank you for your help. He came up with, is this your answer, Talia, 0.63194?
Oh, yeah.
But he kept it in fractions to make it pretty. So we had that right number, okay? Then he did 1 over 50/40, which he says is 0.002. Then he took the answer you had. Oh, okay. Here's his answer. Yeah, he did it in two pieces. Look at 63174. Did we have that?
Yeah.
And 63214?
Yeah.
We found what the sum could be. Now, the questions on the AP would be, could the remainder be less than 1/10? And in this case, our remainder was 2/10 hundredths thousand, 2 10,000ths, which is 1 over 5,000ths. So yeah, we found out what our remainder was, 1 over 5,000ths. Very small. So if you think about it, we didn't even have to go to infinity to get a good estimation. Anybody in this room would be happy to say, how much money do I have in the bank? I have 0.632 because this rounds to 2, right? That was a 2. So we know that if we went all the way to infinity, we're around 0.632. That's pretty cool to know that I don't really have to add up to infinity to have an approximation for the sum. I think it's cool. To somewhere else. Okay, I have some blank slides because I was going to put another problems. Let me go look for one. We'll get to one. Okay, in my notes here. I have some problems at the end of this. Then I'll go back to where I left. Oops. Let's look at copy me in the right place. So at one of these. Let's see, this is, that's direct, sorry, that's going to be, oh, that was the, I didn't have time to get your homework you have. Here's one. How do I know A is an alternating series?
The 1.
There's a what?
Because the 1.
Just a 1? There's a lot of 1s there.
The n equals 1.
That's not why.
No.
Nope. Where is there a switch? Adam, tell her where the switch is. Where is there something causing it to be positive, negative, positive, negative, positive, negative, or negative, positive, negative, positive, negative, positive? Which piece is causing that?
The negative one. Oh, the one. The end.
This one right here?
No.
No?
The end equals 1. That one.
That's what Talia said. No, that's not the reason. This is in every single series. Either n is 0 or n is 1.
The negative one.
What about which one? This negative one?
The top one.
This negative one. Tell me about it.
Well, if it was positive or it was.
It's being raised to a power. If this whole thing is a 0, then that'd be a positive number. If this whole thing was a 1, then it's a negative number. If this whole thing is a 2, then it's a positive number. You see what I'm saying? So it's alternating because you have a switch. Now I'm looking at it, n starts at 1. N starts at 1. So when I plug in a 1, what's 1 plus 1?
2,
What's negative 1 squared?
like 1.
Starts out as positive, doesn't it? What if n is 2? What's 2 plus 1?
3,
What's a negative 1 to the third?
-1.
Negative, see? There's my alternating series. That's why it's alternating. Okay, so you can't do an alternating series test unless you know it's an alternating series. Now, what is A sub n? What is everything except for the switch? You have to know this. You can't do the test if you cannot tell me what A sub n is.
Oh, n over 2 and minus 1.
Perfect. That's A sub n, okay? So we have to do two tests. Step 1, is the limit as n goes to infinity of n over 2n minus 1?
Plus 1, right? Aren't you doing plus
It's a minus. You told me it's a minus.
Yeah, but aren't you doing
I'm just doing the A sub n.
Oh, okay.
Whatever you told me is what I'm doing. What is the limit of this? This is an old problem from the old days. What happens if you plug in infinity? What do you get?
Infinity over infinity?
And so what do you do if you get infinity over infinity? What was another trick we did? Started with an L, an apostrophe, then an H. Looks like a hospital.
I don't know.
L'Hôpital's rule.
Oh,
L'Hôpital's rule says when you get an infinity over, now we could do algebra, we could have done this differently, but if you got infinity over infinity, L'Hôpital's rule says that you can do the limit of the derivative of the top over the derivative of the bottom. What's the derivative of n? Just pretend it's an x. What's the derivative of x?
So it has a 1 right
A 1. What's the derivative of 2n minus 1? Pretend it's 2x minus 1.
1. It's a 1.
Are you sure?
Let me think.
2 times 1 minus 1. Oh. Oh, 1 over 2.
So are you telling me that it's a 1 over 2?
2.
No.
So the answer is a 2 as I was looking for, right?
2.
And so what's the limit as n goes to infinity of 1 over 2?
1/2.
There's your limit.
So no,
Why not?
because it does not equal 0.
Touche. 1/2 does not equal 0. Therefore, now, we don't know it diverges. We do not know it doesn't converge, and we do not know that it diverges. All we can say is we cannot.
So is Hoser next week?
I don't know. I don't think it's next week. I think it's the week after.
Oh, it's the week after.
And
Spring
then,
break.
oh,
The
wait.
week after?
It's the week after spring break.
But I don't know what's going to happen because they had a big meeting in the district regarding state travel. They're going to start limiting students traveling in the state now because of the small number of cases of that virus.
Yikes.
Cannot conclude convergence nor divergence with the alternating series test because Talia said it doesn't equal to 0. So we don't know it converges or diverges. I know for a fact that we can't say it converges. Even if we looked at the other part, okay? Let's do the next problem. Do one more of this, then we'll move on to what the rest of the PowerPoint said.
So can I raise your issue?
You're gonna leave us all alone? Go fast, I'm gonna hit pause. We are back. Adam's back. Talia's still here.
How long
All
did
right.
it take?
So that,
How long did it take?
yeah, like a minute and a half, 2 minutes. So first of all, we have to identify what is a sub n. We identified there's a switch. There's a -1. There's a -1 to an n power, meaning it's going to switch on and off, negative to positive, negative to positive. So it is definitely alternating series. What's a sub n, Adam, if I take off that switch? What's left? 1 over n squared. So let's do our two conditions. Condition 1, the limit as n goes to infinity of a sub n is. What would it be in this case? What is 1 over infinity squared?
1 over infinity.
Which is? Any constant over infinity approaches what number? The amount of pizza that Talia's going to get. 0.
So, yeah, it's the first.
That one checks out. What's the next test? A sub n plus 1 has to be less than or equal to a sub n. Do I have it right, Talia, this time?
Yeah.
Okay. So what I'm going to do is just generically say if a sub n is n squared, I'm going to write 1 over, what am I going to write?
1 squared.
No,
Oh,
n plus
plus
1 squared has to be always less than or equal to 1 over n squared, because that's my a sub n. Let's do the algebra. Multiply this straight up. N squared has to be less than or equal to, multiply straight up, n plus 1 squared. Will that always be true?
Yes.
Give me any n. N is 7. 7 squared, 49. Is that less than 7 plus 1, which is 8? 64.
64.
Yeah, yeah, yeah.
It'll always be true, won't it? If you're adding 1 to n and you're squaring, it's going to be bigger than just plain n squared by itself. Is that correct?
Yes.
So it checks out. Does this converge? We would say that the summation as n goes from 1 to infinity of a -1 to the n over n squared converges by the alternating series test. So we did 3 good problems. Okay, let's go. Fun.
No, it was not fast.
Fast, right?
Okay. Oh, these are notes on what we were doing here.
Oh my God, it's almost time
For what?
to go home.
No, don't say that. I'm having too much.
When it was 3:30, I was like, oh,
Okay, here's one. We got -1 to the n plus 1 over n factorial. Well, yeah, it's almost like what we just did, isn't it?
yeah.
Is that the same problem we just did?
I don't think so, but I think it's like it. Is it?
We had a 1.5. No, we had a 1.5 and a 1/6. I don't remember.
Oh yeah, it is the same problem.
Same problem. Doggone it. Can't use it. Something different, though.
You should wrap it up.
He says,
Just kidding.
no, we still got at least 5-6 minutes. Approximate the sum of the series by using the first 4 terms. Okay, let's do it. First 4 terms. Since we already proved it was a converging alternate series, the limit as n went to infinity was 0, and n plus 1 term was less than the n term. So let's do the first 4 terms. We'll do the first term. Approximately. Put in a 1. That gives me a -1 squared. That's a 1. 1 over 1 factorial is 1. Put in a 2. That gives me a 3. So it's going to be a negative. 1 over 2 times 1 is 2. Now n is a 3. That becomes plus. 1, no,
No, not that.
6th.
Oh, yeah, 1/6.
3 times 2 times 1. That's 1, 2, 3 terms. Well, one more term, minus. That's 4 times 3 times 124. Okay. Letter A. Please, Talia, add those numbers up.
Okay.
Is approximately
0.5
plus 1 over 6 minus 1 over 24.
It's like 0.82 something.
Oh, I messed up.
It's like 0.8, I remember 0.825 or 0.625.
Yeah, but we only got 4 terms.
Yeah, it was.
We had 6 terms.
Hold on, I'm
Just go up.
It doesn't let you do that. Oh, sorry. It's because I had just said that.
Yeah, she just said that.
0.625.
0.625. Give me more decimals.
Told you, sir.
That's it.
Oh, exactly 0.625?
I told you, sir.
Wow, okay. So then use the alternating series error bound to show that the approximation differs from the actual value by 1 out of 100. Okay, so here goes. What number do I need to calculate? Plus the next term would be a what? 1 over
1 over
24 times 5.
120.
120. Please calculate 1 over 120. So the remainder will be, well, what is 1 divided by 120?
0.0083.
0.0083.
3125. No, it's just 83.
Exactly? That's it?
Oh, no. There's like
0083.
2, 3, 4, 5, 6. There's 7 3s.
Oh.
Oh, I don't need all those. I'll just stop with 4 of them. Okay, so here goes. That's my remainder. So what do? I've got my sum that Talia gave me as 0.625, and I'm going to add to it the 0.008 and a whole bunch of 3s. She's going to do that for me. Then she's going to do 0.625. She's going to subtract 0.0883333.
Okay, so the one with. Oh, no, never mind.
Is it 83333 or 8?
I got 4 3s. She said there was 7 of them, but I just took 4.
Oh, it's because I'm asking for the 2 8s. Because up there you have.
Okay, so if you add, it's going to be.
833, 833. Oh, yeah, that's what you're saying. I put a lot of 3s. We'll just use 4. What'd you get?
Okay, so if you add, it's 0.6333333.
A lot of 3s. Okay. And the other one?
0.541667.
Okay.
It sounds like a
So,
number.
so those are here's my true sum. And we know that it could be less than the bigger one, or equal to 0.63333, or it could be bigger than or equal to 0.541667. But what was the question? He was asking me, is the differ by 1 out of a 0.01? Well, let's see. 0.01. No, 0.01 would put me to 0.55. 0.01 would put me here to 0.62 to 0.64. So I'm going to look it up, but I think the answer is it's not less than 1 out of 100. So I'll have to find that solution and see. Then it said, use your results to explain why S does not equal to 0.7. Oh, because look it. I answered the question then. Why it's not 0.7, because we just did it, the work. It's never going to be 0.7, is it? We just did the work. It's never 0.7. It's between 0.54 and 0.63 if we did the work right. I'm concerned about this one though.
Which one?
Minus one, 0.625 minus 0.8. That is right. I think she's right. We did the work. There's my interval. Ta-da. All right. We will stop now. I got a paper for you. I'm going to send to the other people. Bye, everybody. Well, he asked